In this video, we will define the notion of evaluation of a field. So in the last video, we talked about the p-adic absolute value on Q, and that turns out to be an example of evaluation. So let's get to the definition. Evaluation of a field K is a mapping from K into the real numbers. So it assigns a real number to each element of K such that for all elements A and B in K, we have the following properties. First, it's that the absolute value, or the valuation of A, is greater than or equal to 0 for all A, and that this is equal to 0 if and only if A is equal to 0. The second one is that the valuation of a product is equal to the product of the valuations. And the third is the triangle inequality, that the valuation of a sum is less than or equal to the sum of the valuations. So some texts will call this the absolute value, an absolute value of a field. But I'm calling it evaluation. So if, in addition, not only do we have the triangle inequality, but we have that the valuation of the sum is less than or equal to the maximum of the two valuations, we call this valuation a non-Archimedean valuation. And we've seen an example of a non-Archimedean valuation. The p-adic valuation is a non-Archimedean valuation of Q. And we call it the p-adic valuation. And any valuation that is not Archimedean, that is not non-Archimedean, is called Archimedean. So we actually define non-Archimedean first, and then define Archimedean to be not non-Archimedean. And of course, the typical example will just be the regular absolute value on R is Archimedean. Okay. One thing to keep in mind is that sometimes you have a mapping defined on an integral domain and you want to extend it to evaluation in the quotient field. So there's a useful theorem. So here we defined valuation on a field. So suppose that you have an integral domain. Suppose that A is an integral domain. And you have a mapping, say, this mapping with the subscript 1 from A into the reals, satisfying these conditions. let's call these conditions 1, 2, and 3. Then this mapping can be extended uniquely to evaluation on the quotient field, evaluation of the quotient field. Of A. Okay, well, the sketch of the proof, maybe I'll just say the idea of the proof. Well, it's kind of what you would think it would be. I mean, if you have an element of the quotient field, then we can write it as the quotient of two elements of A, right? So you define the valuation of X to just be the, what do you call it? The mapping, the map of A divided by the map of B. And then you check, well, certainly if you think about it, one is required to find this in order for the valuation to be extended. Or in order for the map to extend to a valuation, I mean. And one can check that this is a valuation. So check that this is a valuation. On K, the quotient field of A. So that's just a useful thing to keep in mind. Okay, so some properties of valuations. One of them is that the valuation of 1 is 1. All right. That's just because this is the identity element, 1 being the identity element of the unit element of K. It's because the valuation of 1 times 1 is by property the valuation of 1 times the valuation of 1, and 1 times 1 is 1. So you have that the valuation of 1 is equal to itself times itself, and so since the number is positive, we know that the valuation of 1 is equal to 1. Okay, similarly, the valuation of negative 1 is 1. Remember that, okay, it's confusing because of the notation, but hopefully we understand that this 1 is just the unity in the field, and negative 1 is the additive inverse of the unity in the field, and then this is actually the number 1 in R. Right? Okay, we also have that the valuation of A over B, so this is just A times B inverse, is equal to the valuation of A over the valuation of B, and also that the absolute value of the valuation of A minus the valuation of B is less than or equal to the absolute, the valuation of A minus B. Oh my goodness. So the notation is certainly kind of confusing. This denotes the absolute value of a real number because, you know, this and this are real numbers, right? Whereas here, this is actually on the right, you're talking about the valuation on the field. Okay, so this last one would be a good exercise. Okay, but it basically follows from the definitions. Okay, well, in the next video, we'll see what happens when you have a non-Archimedean valuation. So when you have a non-Archimedean valuation, it has additional structure, and we'll define something called the valuation ring associated with the non-Archimedean valuation.